Back to our lecture series on control system. Today we are discussing some problems. Also, we are doing some problems on Mason's gain formula. So in the last class we discussed Mason's gain formula in detail. What is the procedure to draw a signal flow graph, and mainly Mason's gain formula is using to find the transfer function from signal flow graph. That may be output by input. The output node may be any node. We can convert any node to output node, but the input node is ideally a single node. So all those things were discussed in last class, and now we are going to some more problems on Mason's gain formula. So I'm directly starting first problem. Okay, please read the question. Convert the given block diagram into signal flow graph and determine C of S by R of S. What is C of S by R of S? C of S is Laplace transform of output, and R of S is Laplace transform of input. So, Laplace transform of output by Laplace transform of input is nothing but transfer function. It is the transfer function. So, you are asked to find the transfer function of a block diagram using Mason's gain formula. So for applying Mason's gain formula, we have to convert any block diagram into signal flow graph. So questions may appear like this. You may be given with a block diagram, and then you are asked to find transfer function using Mason's gain formula. There are other methods also for finding the transfer function of a block diagram that we will discuss later. But anyhow, in this question specifically, they are asking for converting the block diagram into signal flow graph and to find the transfer function. So for finding the transfer function of a signal flow graph, the one and only method we are using is Mason's gain formula. Okay, now I am going to converting this into signal flow graph. So in step 1, what is the step 1? We have to identify which are the nodes. So nodes are assigned at input, output, at every summing point and branch point. That is the important thing. In signal flow graph, if you are getting directly a signal flow graph, you don't need to worry about which is the node, what is the branch gain, such things. Everything will be given directly. But in this problem, it is a block diagram, so you have to identify which are the nodes. So input will be a node, output will be a node. That is very clearly understood. But where the other node should be given? So that is the first statement. Every summing point, which is summing point in block diagram, we can see it is a summer. Plus, minus, such things are given. It is a summer. So each summer will be a node. Okay, node means in previous example we took nodes as x1, x2, x3, etc. In this problem, I just simply take 1, 2, 3, 4, 5, 6. That is your choice. You can mark x1, x2, x3 or 1, 2, 3, 4, 5. No problem on what way you are naming the nodes. Okay, so the summing point will be a node, and each branch, because in between this summing point and this block, there is a branch. And that is going to another block through another path. So which is a branch. At every summing point and branch, we have to assign nodes. So in this figure, we can see 2 branches are initiating in between. That is, in between the summer block and G1, a new branch is initiating. It's a branch point. And in between G1 and G2, there is also a new branch is initiating. That is also a branch point. So 3 and 4 are branch points. So 1 and 6 are node 1 and 6 are input and output. Node 2 and 5 are summing points. Then which are the branch points? Node 3 and 4. Node 3 and 4 are branch points. So now I simply got that there is 6 nodes. So initially what I am going to do is I will mark 6 nodes in a blank paper. This is the first step for drawing signal flow graph. I marked 6 nodes in a blank page. And second stage, I am connecting all the 6 nodes. That is, I am connecting simply from input to output. Anyhow, there will be a path from input to output. Anyhow, there will be a path from input to output that is clearly visible in the first case itself. This is the case. In any problem, you can simply say there will be a path between input and output. That is a simple path. But there may be another paths also for traveling from input to output. Such paths are known as forward paths. In last class, we discussed the gain of forward path or gain product of forward path gain. Such things we can name it in different way. So anyhow, first I am connecting all the nodes to get the first forward path. This is simply a first forward path. 1, 2, 3, 4, 5, 6 is the name, or you can call as x1, x2, x3, x4, x5, x6. So it is a first forward path. Now I have to analyze which are the other forward paths. In block diagram, generally there may be forward path and backward path. What is the backward path? You have to take some feedback from output to some input nodes or towards some previous nodes. Such things are known as backward or feedback path. Okay, anyhow, in this question we can see from the point 3 to the minus of summer, there is a branch, and the gain of that branch or the function of that branch is named as G3. So in block diagram you can see G1, G2, G3, such things are marked. Previously we discussed that these all are some Laplace transformation of some mathematic functions. It may be a differentiation, integration, such things. I think you remember the class. If you are having any doubt, you can check or you can refer the mathematical modeling of a LTA system. I think it was the lecture 3. In that, it was very clear how we got the transfer function, and in that we will get some terms in the form of S, that is the Laplace of differential equation, ordinary differential equation we get from the modeling. Similarly, here while modeling we got a number of blocks, that is the block diagram representation. It may be integration, differentiation, such things. In integration, normally we can say Laplace transform of integral is represented by 1 by S form. Laplace transform of differentiation is represented by S form. So normally S or 1 by S terms appears in G1, G2, G3, etc. And H may be also a process, maybe a simple gain like 2, 3, 4, such things happen. If in problem these things are given, you have to use that values. Otherwise, you can simply use G1, G2, G3. That are the representation of the process or representation of the gain. So, what I want to say is from 3 to 5 there is a path. From 3 to 5 there is a path, and that path is also contributing a forward path. You can see from 1, 3, 5, 6, that is also contributing a forward path. But you should be very careful about the point where it is landing. It is landing in the summer at the minus port. It is landing in the minus port. So you have to take the gain or the function block as minus G3. That is the very important thing. For all the summer blocks, if you are landing with some functions, you should check where it is landing, whether at plus or minus. If it is plus, you can take positive signal for the positive magnitude for the function or gain. If it is in negative, you have to take negative polarity for the function or gain. Okay, so we can see in the next figure, I connected minus G3 from 3 to 5. It's very clear now, minus G3. And this will be minus H. This is a backward path. It is traveling from 4 to 2. You can see, okay, I will mark the arrow mark also. This is the arrow mark. Okay, so you have to draw that arrow mark also. It is from 4 to 2 minus H. But why we took it is minus negative H? Because in the node 2 there is a summer, and in that summer the signal is landing at minus port. So we have to take minus H. So I think this is very clear up to the moment. Now we are going to next slide. Which are the forward paths? I already explained. We can simply see two forward paths. One is the direct forward path from node 1 to node 6, and its name is 1, 2, 3, 4, 5, 6, or x1, x2, x3, x4, x5, x6. And what will be the gain of that particular path? Gain is denoted in signal flow graph. Gain of forward path is denoted as M1, M2, etc. So what is M1? M1 is gain of first forward path. What is M1? Please look. What is M1? You can look here. 1 into 1, because in the problem, in the basic question, it is given there is no magnitudes in between node 1 and 2. It is a straight connection. In between 2 and 3, no gain, because it is a simple connection. If there is some gain, you will be given with a box, square box, and value may be there 2, 3. In such case, you have to mark in between 2 and 3, you have to mark a magnitude other than 1. But in this problem, no such magnitudes are given. So you have to take all branch magnitudes as 1, except where G1, G2, G3, H1, etc. are coming. So in between 1 and 2, no extra gains are given. So 1. In between 2 and 3, there also it's 1. In between 3 and 4, there is a block G1. In between 4 and 5, there is a block G2. So gains of these nodes are G1 and G2. In between 5 and 6, again it is 1. So we can see the forward path, first forward path 1 to 6 is having a gain G1 and G2. G1 and G2. M is equal to G1 and G2. And second forward path is 1, 2, 3, 5, 6. And gain of that path is, which is the function appearing in that path? Only G3 is the function other than 1. So the gain will be minus G3. So now you get two forward paths. First is G1, G2, and second is minus G3. Is there any other forward path? Please think. Is there any other forward path? No, because you can simply see that in this block diagram itself, you can see from input to output there is only two paths. Because if you are taking this path, is it a forward path? No, because arrow mark direction is changed. In between 2 and 4, arrow mark is in opposite direction. So you cannot take that as a forward path. So simply you are having two forward paths. Now the next step is loops. You have to identify the loops. Okay, I can say there is only one loop in the particular signal flow graph. Which is that loop? It is two, 3, 4, 2. Why so? Because this direction is consecutive. 2 to 1 arrow mark is positive, 3 to 4 arrow mark is positive, 4 to 2 arrow mark is positive. Please draw an arrow mark here. Please draw arrow mark here like from 4 to 2. So in this loop all the arrow marks are providing a consecutive or successive direction. But what about 3, 4, 5 tree? Please check 3, 4, 5 tree. From 3 to 4 arrow mark is okay, from 4 to 5, but from 5 to 3 the arrow mark is just opposite, so it is not a loop. So the one and only loop is 2, 3, 4, 2. So I have drawn that case here. This is the loop and its gain is, there is a G1 block in between 2, 3 and 4 and there is a minus H block in between 4 and 2. And the loop gain is, so minus G1 into H. It is just the multiplication of those functions, minus G1 into H. Now, as there is only one loop, no need to think what are the 2 non-touching loop, 3 non-touching loop, all those terms will be 0, because as there is only one loop, how we can comment about non-touching case? If there is 2 loops, I can say whether these loops are non-touching or not touching. But till now I am having only one loop, so I cannot comment anything about the case like how many loops are touching or non-touching. So all those terms in the delta equation will become 0. Gain product of 2 non-touching loops is equal to 0 because only one loop in signal flow graph. Gain product of 3 non-touching loops, that is also 0. Okay. So delta, what was the equation of delta? 1 minus, please remember, I have not written here because it was discussed very clearly in the last class. What was the equation of delta? 1 minus gain product of individual sum of individual loop gains. That is, if we are having 3 loops, it will be 1 minus L1 plus L2 plus L3. After that, plus sum of gain product of 2 non-touching loops, because if L1 and L2 are non-touching and L2 and L3 are non-touching, it will become plus in bracket L1 L2 plus L2 L3, like that. But in this case we know that only we clearly know there is no such terms, only first term and second term. First term is 1 minus second term is sum of individual loop gains. There is only one loop and its loop gain is minus G1H. So we substitute here 1 minus G1H. That will become 1 plus G1H. That is the delta. Now it is the time for going for delta 1 and delta 2. What is delta 1? Delta 1 is the delta value which is non-touching on first forward path. And delta 2 is delta value which is non-touching on second forward path. It is also very simple because this is the first forward path and the delta value means this is the first forward path. In that we are checking whether the terms are touching, the terms in delta are touching in or not. Anyhow, in delta there is 1 minus L1. That was the basic expression of delta we obtained. Value of L1 we know. Now for the time being I am taking it as loop 1, L1 only. I am not using the value. And this is the first forward path. I am asking whether the first forward path is touching on loop 1 or not. Yes, it is touching because loop 1 lies here, 2 to 4. Sorry, not 2 to 4. It lies in between 4 to 2. It was the loop 1. So this loop completely touches on first forward path. So the term L1 become 0 in delta 1. So already delta equation was 1 minus L1 and the L1 is touching on first forward path. So delta 1 becomes 1 only. And delta 2, that is also very clear. Delta 2 is depends on second forward path. In second forward path, the loop comes in between 4 and 2. The loops come in between 4 and 2. So it touches at 2. The loop touches at 2 where the second forward path is passing. So no choice. Delta 2 is also depending on its forward path loop. So in the delta equation, 1 minus L1, the second forward path also touches L1. So delta 2 becomes 1 only. L1 will become 0. So this is delta 1 and this is delta 2. So before going to delta 1 and delta 2, first you should clearly visualize what is delta equation. Where the loops are standing. Is the loops are touching on the forward paths or not? So while analyzing delta 1, you have to memorize only first forward path, and you have to memorize whichever loops are there and whether the loops are touching on the path or not. If the loop is simply touching on the path, you can give those loops values as 0 in the delta equation. That's why in the first forward path, L1 is touching. So this L1 becomes 0 in the delta 1 equation. So delta 1 is 1. In the second forward path, again L1 is touching. So that will be again become 0 in the delta equation. So delta 2 also becomes 1. That is the case. Now I am finding the transfer function. Sigma k is equal to 1 mk del k by del. That is, as there is 2 forward paths, n is equal to 2. So m1 del 1 plus m2 del 2 by delta. So m1 is equal to g1 g2 and m2 is equal to minus g3. And delta 1 and delta 2 are 1 and delta is 1 plus g1h. I am directly substituting all these values and this is the transfer function equation. This is very simple. Okay. Now I am going to a second problem. Okay, these two problems are almost similar, but here instead of g1, g2 such things, I am giving the functions of Laplace domain, that is 1 by s, 1 by s, 1 by s, and the other things are simply 1. So in between x1 and x2 it is 1, gain is 1. In between x5 and x6 also gain is 1. And the feedback you can check from x5 to x3. It is not a function, it is simply minus 1. Why it came minus 1? Actually, its magnitude is 1 and it is connected to the minus of that summer. That is the case. That's why it appears minus 1. If it is represented in the block diagram, in x3 there will be a summer. And in x2 also there will be a summer. And in both these summers, the feedback is given to negative portal. That's why these feedbacks are marked with minus value, minus 1 and minus 1. Okay. So we can analyze the question. How many forward paths are there? Simply, in any problem, this will be the first forward path, x1 to x6. Which is the second forward path? x1, x2, x5, x6. That is also a forward path. Is there any other forward path? Please check. No, all the other paths are reversing its direction. So, and it may be traveling more than once in nodes. So these are the only two forward paths in this problem, m1 and m2. Okay. So first path, number of forward path is equal to 2. First path is x1, x2, x3, x4, x5, x6. And its path gain is 1 by s, 1 by s, 1 by s into 1. So it will become 1 by s cube. 1 by s cube. It is here 1 by x cube. And the second forward path is, I already told you, x1, x2, x5, x6. It is also drawn here, x1, x2, x5, x6. In between, in this path, the only function is a 1 by s and all the other are unity. So the path gain is just 1 by s. So m1 is equal to 1 by x cube and m2 is equal to 1 by s. These are the two forward paths. Now I am going to check which are the loops. First loop name is x1, x2, x2, x3, x4, x2. We will check it in the first case. Okay, this is the case. X2, X3, X4, X2. All the direction of arrow marks are consecutive or successive. And second forward path will be, you can see here, X3, X4, X5, X3. We have to find the gains. Now I am just commenting about the name only. X3, X4, X5, X3. What is the gain? 1 by S, 1 by S into a minus 1. So that will become minus 1 by S square. So L1 and L2, both the loops are having same function, that are minus 1 by X square. Is there any other loop? Please check. It's a task. You can pause the video and check. Is there any other forward paths? Yeah, there is one more forward path. But you can simply identify that forward path. It is little bit complicated. For the time being, I am explaining it. You can check by pausing the video by yourself. But as we are having a time limitation, I am simply giving the forward path. X2, X5, okay, X3, okay, X4, okay, X2. What were the conditions? We are not allowed to repeat to travel through any node more than once. That is satisfied. And all the direction of arrow marks are consecutive or successive. Not opposing arrow marks are appearing. Once more, I will explain. X2, X5, X3, X4, X2. That is the third loop. X2, X5, X3, X4, X2. And the gain of that path is 1 by S square. You can check. You can check that. Gain of that path is 1 by S square. So L1's gain is minus 1 by S square. L2's gain is minus 1 by S square. And L3's gain is 1 by S square. Okay. Now it is delta. Delta is equal to 1 minus sum of individual loop gains L1, L2, L3, sum of gain product of two non-touching loops minus sum of gain product of three non-touching loops and so on. But here L1, L2, L3, all these three loops are touching in all cases. L1 is touching L2, L2 is touching L3, L3 is touching L1. So the third term from first term 1 will exist and the second term L1 plus L2 plus L3 will exist. From the third term all the other terms will be 0 because no non-touching case appears for these loops. You can please go to the first slide and verify, or you can please rewind this video and verify that. Now I am going to substitute 1 minus, first loop is minus 1 by S square, second loop again minus 1 by S square, and third loop gain 1 by S square. So plus 0. Okay, so 1 minus 1 by S square minus 1 by S square plus 1 by S square, that is the value of delta. And now delta 1. Delta 1 is the first forward path that coming from 1 to 6. Okay, we can check here. This is the delta 1. So this is the first forward path 1 to 6. And all the loops are touching on that forward path. So in delta equation, L1 becomes 0, L2 becomes 0, L3 becomes 0. Then what will be there in the delta equation? All the L1, L2, L3 are become 0. Then what will be there in the delta equation? Only the thing there remains there is just 1. So again in this problem also delta 1 is equal to 1. And what is the case of delta 2? I have drawn the second forward path in the blue color. This was the second forward path. And this was the loop L1 that is touching in this point, and this was the loop L2 that is touching on this point. And what about L3? It will touch on all points because it is a complicated one. I have not drawn there. So in the second for the case of second forward path also, it is touching on all the loops L1, L2, L3. So the only thing remain in the delta equation is 1, because L1, L2, L3 all are touching on the forward path. So delta 2, also becomes 0. All two loops are touching on M2. So delta 2 is equal to 1 minus 0, that is also equal to 1. But be careful, in all problems this will not appear. You have to do some more problems by referring textbooks. Then you may get some case where delta 1, delta 2 are existing. Not existing. Loop values are also existing in the equation of delta 1, delta 2. So transfer function is equal to sigma k is equal to 1 to n mk delta k by del. So two forward paths. So m1 del 1 plus m2 del 2 by delta. I am substituting m1 1 by s cube delta 1 1, m2 1 by s delta 2 1 divided by delta value. Directly delta value is written here. Now it's simplifying. Okay. In the numerator we can see 1 by s3 plus s. Okay. So I am taken s3 as LCM. So it will become 1 plus s square by s3. And in denominator I just kept like it by opening the bracket 1 plus 1 by s square plus 1 by s square minus 1 by s square. These two terms will get cancelled. 1 by s square minus 1 by s square. This will get cancelled. So the things remain balance are 1 plus s square by s3 by 1 plus 1 by s square. 1 plus 1 by s square become s square plus 1 by s square here. S square plus 1 by s square, and numerator is 1 plus s square by s cube. So in both the numerator, upper part will get cancelled. It will become s square by s cube. That will give 1 by s. So this is the beautiful answer. In this case you got some short answer, because if you are in the problem, if you are given with the things like 1 by s, 1 by s square, 1 by s cube s, such case are given instead of G2, G3, then you can just simplify and will get some simple terms like this. Otherwise you don't need to go simplify and all. In the last case we can just simply substitute things and keep like that only. If these are in the terms of s, then you have to do some simplification if possible, if time permits. Otherwise don't waste time and don't do some wrong calculations also. So these are the two problems I am doing in the Mason's gain formula, and I am also requesting you to refer the textbooks like simple textbooks like Nagorkani or yeah, for the gain Mason's gain formula, Nagorkani itself is sufficient. There is 6 or 7 problems in that textbook, so you can refer that and you can do some more complicated problems and also make notes on that problems also. So we can meet in the next class. Thank you.